Hello class, we are doing inscribed angles and polygons part 1, so please turn to your appropriate section of your notes for 11.5. First, a central angle is an angle whose vertex is the center of the circle, and it looks like this. Please put a center point in your circle. And then next, an inscribed angle is an angle whose vertex is on the circle and whose sides contain the chords of the circle. So an inscribed angle inside the circle, and the vertex point is on the circle. I guess they're both inside the circle, it just depends on where that vertex is. A central angle has the center as its vertex, an inscribed angle is on the circle. We've discussed major and minor arcs already, how if you have a minor arc or a major arc, it's going to be the measure of this central angle. And let's put in our picture the letters A, C, and B, so that way it corresponds with this notation down here that the measure of the arc AB is going to be equal to the angle ACB. Let's also insert the following letters into our picture for intercepted arc. The arc that lies in the interiors of an inscribed angle, so the arc that lies on the interior, so that's this arc AB, and has endpoints on the angle, we can assume this formula fits. So the measure of this arc AB is equal to twice the measure of this angle, ADB. We can also go the other way, that this measure of this angle, ADB, is half the measure of the arc. So an example in this, if we see the central angle is 50, then its arc is 50. If the measure of an inscribed angle is 50, then its intercepted arc is 100, and vice versa. If you see an arc having 100, then its inscribed angle is half of it. So with this following picture, and you will probably need to pause because I'm going to go straight through. With this following picture, if I see this inscribed angle of NMP being 45, then its intercepted arc, NP, is going to be twice its measure. Formally writing, we have this formula. The measure of the arc is equal to twice the measure of the inscribed angle. So the measure of the arc NP is equal to twice of 45, so it's going to be 90. Next example. If this angle, KMP, is 120 degrees, then that intercepted arc, K to N to P, is going to be twice the amount of that inscribed angle. Formally speaking, we have the following formula, and we're going to plug in 120. So the measure of that major arc, KNP, is 240. Now we're going to see the reverse side. What if we're given the measure of an arc? How do you find the inscribed angle? So it goes the opposite way, where instead of multiplying by 2, this 180 will be cut in half to find the inscribed angle. Formally speaking, we have the following equation. Measure of the inscribed angle is equal to half the arc. We plug in 180, and we get 90 degrees for the measure of that inscribed angle. Next example, again, we're going to have the measure of this arc, so the measure of that inscribed angle is going to be half that size. This will be the formula, formally speaking. We plug in 84, and this inscribed angle is 42 degrees. So in this next example, we'll see how can we connect everything. We've got a measure of arc DP being 85. Measure of angle DPG is 50 degrees. Measure, we don't have a central intersection labeled, so be sure you put 65 degrees in its appropriate spot. And we're going to find every single one of these arc measures or angle measures. So with the first one, from D to G, sometimes a highlighter or trying to see where's your intercepted arc, where's your inscribed angle. So if I look at DG, it has an inscribed angle of DPG, and we actually have an angle measure for DPG, and it's 50 degrees. So for this formula, the measure of this arc will be equal to twice the measure of the angle DPG. So taking twice of 50, that arc measures 100. First we have to locate angle PDX. So if I look at PDX, I'm looking for this angle. Notice how it's inside a triangle. Sometimes we have to go back to chapter 1 and realize, okay, this inner triangle has to add up to 180. So if this is 50 degrees, I can find this angle by using vertical angle theorem. This will be 65. So looking at that triangle, I'll be taking 180 minus 50 minus 65. Their sum is 115, away, and take it away from 180 is a measure of 65. So the measure of that angle is 65. If I'm looking for measure of angle GX to D, I have to map it GXD. GXD. Notice how it actually intercepts this arc DG. So because I know what this arc measure is, I could use that to figure out what this angle would be. Since arc DG has a measure of 100, I'll cut that in half to get this angle. So cutting it in half, measure of angle GXD is 50 degrees. Going to arc PX, I notice that if this is what I'm trying to find, using the formulas we have today, it intercepts this inscribed angle. And we just found what that angle is. It's 65. So to find its intercepted arc, we're going to double it. So this gives us a measure of 130. The next one we're going to find measure of angle PGX. So if I map that out on my diagram, PGX, I've got this angle, and it's intercepting the arc I just found that we have as 130 degrees. So to find that angle, I'm going to cut this in half, getting us 65 degrees again. In the next one, we have arc XG. So if I look at arc XG, I would love to say that it is twice this angle, but the bad thing is this is not an inscribed angle. Inscribed angles have to be, this vertex would have to be somewhere on the circle at some point. So I cannot just double this angle. I'm going to have to use a different resource. We have actually found all of these other arc measures. Well, we actually didn't find this 85. It's already been there, but we found DG, arc DG to be 100, and we also found arc PX to be 130. We could add these arcs up and subtract from 360. We get a total of 315 between all three of those. We'll take it away from 360. We get a measure of 45. So that arc is 45 degrees. To find the last one, we'll use the same idea. In order to find arc DPG, we will have to take 360 and subtract. Well, I guess we don't. We could take 85 plus 130 plus the arc that we just found, 45. That would give us the answer. We get a measure of 260. So to recap what we've learned today, in order to find the measure of an arc, we double an inscribed angle. In order to find an inscribed angle, like we did for this one, this DXG, in order to find an inscribed angle, we take half of the intercepted arc.